Welcome back to eCoreAcademy, students. My name is Anita Raj, and I am one of the teachers and co-founders here, along with my younger brother, AJ. Today, I have a new Algebra 2 lesson for you after a one-day break where I did anatomy and physiology. Coming back to Algebra 2, we're going to be finishing our Modeling with Quadratic Functions mini-series. This is part 3, and we're mostly going to be focusing on 2 practice problems that I've prepared for us to go over. So, like I said, we're going to be working through 2 problems. The first one involves a table, as in an XY table, and we're going to have 3 points. We're going to be trying to find the quadratic function that goes through the quadratic equation that goes through all 3 of those points. And the other one is about a ball. So it's going to be an application, and we're going to be working through that together as well. Before you even start watching this video, I would really appreciate if you paused and liked the video to show your support towards AJ and myself as content creators here at eCoreAcademy. Also, subscribe to the channel if you want to join our rapidly expanding student community, and hit the post notification bell so you're notified of our latest posts. Don't feel afraid to drop a comment down below. We love to hear what our students think. And lastly, use our socials in the description box below to share eCoreAcademy with all your family and friends who could benefit from what we're doing here. Okay, let's get into Modeling with Quadratic Functions Part 3. So this is going to be our first problem. Like I told you, it's going to involve a table, an XY table. So here's the problem. Find an equation in standard form of the parabola passing through the given points. And as you can see, it's x and f of x. Remember, f of x is just your y. It's just a different way of writing y. So it's just an xy table. F of x just substitutes y. So our first point that we've been given is -6, -10. Our second point is -2, 6. And our last point is 2, -10. That's just another way of reading this table by pairing these x and y coordinates together to make full coordinate pairs. So we've been given these 3 points, and we need to find the equation of a parabola in standard form that passes through these points. We've done this before, so let's just do it again. However, I'm going to be showing you a little bit different of a method to solving this. So here is the solution pre-written. Again, I've written the 3 points at the top of the screen just for reference because I can't put that table on every single slide. So -6, -10, -6 and -10, -2, 6, and 2, -10. Here's a solution already pre-written for you. And if you want to just follow along on the next slide where I actually detail this and I go through it, and there's a calculator part that is involved as well, so you definitely have to listen to that as I explain it by mouth. But here is the rest of the work that you should do, that you have to do by hand. If you want to copy it down, feel free to do so. I'll give you a little bit of a pause so you can pause the video and copy it down. Okay, let's move on to the next slide. Again, I'm just going to be going over exactly what's written on this slide, along with showing you how to incorporate the calculator to do a lot of the heavy lifting of this problem solving for you. Okay, let's go to the next slide. The 3 coordinates are written at the top of the screen. Again, we're going to be doing this solution, but instead of having it pre-written, we're doing it together. So let's do that right now. So we have these 3 points. So what are we going to do? Well, we're going to use something called a matrix, and I've gotten over matrices before when you have 3 variable systems. In this case, we're given 3 points. We don't know what A is, we don't know what B is, and we don't know what C is, because remember, standard form. So let me just write standard form right underneath these 3 points. Y equals AX squared plus BX plus C. So given these 3 points, we don't know what A, B, and C are. Therefore, we need to take each of these points, plug each of them into standard form for our x value and our y value, because we know what the x, so if I take -6, -10, for example, we know that x is -6, and we know that y is -10. So we need to plug those values in for the x's and the y's we see in standard form and simplify that as much as possible. We'll do that with each of these 3 points, and then we will take each of the answers we get in simplified form, put it into a matrix on the calculator, and then we will find the final answer. I'll show you how to do that right now. So let's take the first point, -6, -10. Let's plug it into y equals ax squared plus bx plus c. So we're going to be plugging -6 in for x and -10 in for y and simplifying that as much as possible. So let's do that right now. So we can rewrite this as y. Instead of y, we're putting negative 10. So negative 10 equals a times the value, well, x is negative 6, so negative 6 squared plus b times negative 6 instead of x. And then we just have plus c. So let's simplify this even more. Negative 10 equals, well, negative 6 squared is 36, and a times 36, we can just rewrite that as 36a. The next one, b times negative 6, we can just rewrite that as negative 6b. And lastly, we just have that plus c. So that is the most simplified you can go. If you want, you can divide this by 2 to simplify it even. I mean, you can't divide this by 2. I'm sorry. That's just as farthest you can go. That is the most simplified we can make it. So let's move on to the second point, negative 2, 6. We're going to do that right underneath here, plugging negative 2 in for x and 6 in for y. So let's do the exact same thing we just did. So 6 equals a times negative 2 squared plus b times negative 2 plus c. So let's simplify this. So 6 equals, well, negative 2 squared is 4, and a times 4, we can rewrite that as 4a. b times negative 2, we can rewrite that as negative 2b. And then you just have that plus c. So that's the second point, simplified. Now let's move on to the third point, 2, negative 10. Remember, we're plugging 2 in for x and negative 10 in for y. So let's do that right now. So negative 10 equals a times 2 squared plus b times 2 plus c. And let's simplify that further. Negative 10 equals 2 squared is 4. A times 4, we can rewrite that as 4a. Plus, well, b times 2, we can rewrite that as 2b. Plus c. So we just simplified these three equations. Now let's write it in a matrix form just for our sake. See how we have 3 variables instead of x, y, and z? We have a, b, and c. So treat them as your x, y, and z if you're more familiar using those 3 variables in your 3 variable systems. Off to the right, I'm going to just write the matrix that we're going to be putting exactly into the calculator to give you an idea of what we're doing. So I'm going to write that over here. So if you remember, the first row is going to be your first row is going to be focused on your first equation. So the first number you're putting in is the coefficient of your x variable or your a variable in this case. So the first number we're going to be putting in at the top, in this case, look at this first equation, is 36. The second number we're putting in right next to it is the coefficient of your y variable, or in this case your b variable, and the coefficient of b in this first equation right here is negative 6. So negative 6 would be our next value. Lastly, we're putting in the coefficient of our z variable, or in this case our c variable, and because it's just plus c, we can assume that the coefficient is positive 1. So we put positive 1 in. And then lastly, we put what that whole equation is equal to. In this case, in the first one, you can see that 36a minus 6b plus c, all of that is equal to negative 10. That would be the fourth value we put in the first column. And you just have to follow this principle for all 3 of these equations. So for the second one, the coefficient of our a value is 4. Coefficient of our b variable is negative 2. Coefficient of our c value, again, is 1, and all of this is equal to 6. And for our last equation, coefficient of our a variable is, again, 4. Coefficient of our b variable is 2. Coefficient of our c variable is positive 1, and this is all equal to negative 10. So that is how we got the matrix. We wrote it all out. We planned it all out, so we know exactly what we're going to be plugging into the calculator when we are solving. So we're going to be plugging all of these into the calculator. Let me pull up the calculator on my screen so that you can follow along as I solve it. Okay, so here's the calculator. If your calculator hasn't been cleared yet, I highly suggest you do so. So like all the steps have been written out here, second, and then your plus sign for mem 7, 1, 2. So then what we're going to be doing next, you can just hit clear again to get rid of this notification. Then I'm just pulling the calculator to the left so that you can see the matrix we've already planned out over here. To get to your matrix so you can edit it and plug these values in, hit second. Then you want to go to your x to the negative 1. And right above it, you see matrix in blue, so you want to hit that. Take into the matrix screen. Then you want to hit the right arrow twice to go to edit. This is just a review of what we've already learned. Hit 1 so that you can edit matrix A. And then you want to change the dimensions to 3 by 4 because you are 3 down, 4 across. So you want 3 columns and 4 rows. So 3 by 4. And if you just hit the down arrow, you see that whole matrix changes to adapt to what you wanted it to do. And then we're literally just going to be plugging these values in. So the first slot will be 36. Then you can hit you can go to the next slot. Then you have -6. I'm literally just plugging in what we've written over here, and then 1 for the first row, and then the last value is -10. So we just plugged in the first row. Let's go to the second row. The first quantity of the second row is 4. Second quantity is -2. Next quantity is 1. And the last one is -6. Let's finally go to the third row and plug in our third equation. First quantity is 4. Go to the next box, and next one is 2. Then the following one is 1. And the final one is -10. So we just plugged in all of those values. So our matrix is complete. You want to hit second and then quit. And then you want to hit second again, go back into matrix. And for it to be able to compute it and find out what the solution to this is, you want to let me go back to the home screen. You want to hit second and then x to the -1 again. And then instead of going to edit, you want to hit right once and go to math. Keep scrolling down until you get to B. It should say ref. That's on A, sorry. B, ref. And then you just hit enter to select that. So now that your cursor is blinking, you need to put matrix A into this. So in order to do that, hit second and then matrix again. And then it'll bring you to names, and then to select matrix A, just hit 1. And then you can just hit close parentheses, and when you hit enter, you should get the answer. So here you read this. Remember how I told you look at the final column for your answers. It reads -1, -4, 2. In a regular 3-variable system, we interpreted this as the solution for x is -1, solution for y is -4, and solution for z is 2. So we wrote that as an ordered triplet, and we wrote that as -2, -4, -1, -4, 2. In this case, what does it mean? Because we were trying to find the equation in standard form of a parabola that passes through these points. Well, in this case, remember how we're saying x is actually A, y is actually B, and z is actually C. In this case, our A is -1, B is -4, and C is 2. So if you don't understand that, let me write it down here on the screen. So I just minimize my calculator. Let me write it on the screen so maybe you understand it if I write it in standard form. So again, I'm just going to write a down arrow. We use the calculator. If you missed out on that part, please replay it. It's a very vital part of solving this problem. And then our final answer, well, remember how, so our A value was -1. So how would we write that? Well, A comes before x. Look at this standard form over here. And if that's -1, we can just write that as -x squared. Because that A value translates to -1, and -1 goes in front of our x squared term, and we can just write that as a negative sign. Next, we had a -4. That was our B value. So how would we write this? Well, we would write this as -4x. And then our final value was +2 for C, and we would write that as +2. So this right here would be your final answer, and that is exactly how we use a matrix to solve this problem. So I hope you understood that. Please replay it if you didn't. Using a matrix will help you get through these problems very quickly and efficiently. So learn how to incorporate it and try to understand how we use the matrix and how we use those values for x, y, and z to find A, B, and C. And then we rewrote that in standard form. Okay, let's move on to the next problem. So this is going to be an application. Like I said, it's going to be a real-world scenario, and we're going to be primarily incorporating the TI calculator to solve this. So here's your information. This is not even the problem. This is just some important information you should know. in this word problem, the character is AJ. So AJ is the one performing the action, and we're going to be solving this problem for him. So AJ throws a ball off the top of a building and records the height of the ball at different times, as shown in the table. So what is happening? AJ climbed to the top of a random building. Maybe he's in the city, maybe he's not. But he goes to the top of this building, and in his hand, he has a ball. When he's at the top of the building, he reaches the very top. The roof of the building. He throws the ball off the top of the building, and as the ball arches up and then descends downward towards the ground, along the side of the building, he is recording the time in seconds. So at 0 seconds, he's recording what height the ball was at 1 second after he's thrown it. He's recording what height the ball is at, and so forth. So every second, he's just keeping a tally of what height the ball is at. We don't know how he's doing this, but he has given us the information that at 0 seconds, and remember the time is in seconds and the height is in feet. So at 0 seconds, the ball was at 63 feet. At 1 second, the ball was at 68 feet. At 2 seconds, the ball was at 41 feet. And at 3 seconds, the ball was at 8 feet. So this is the information he's given us, and we have to see what is he asking us. So there's 3 parts to this problem that I'll be showing you, but I've written the 4 coordinates that you need to know. If you see on this table right here, I've just translated those into the coordinates 0, 63, 1, 68, 2, 41, and 3, 8, and written them at the top of every screen so you can refer to it, because I can't put that table on every single screen because it's too big. So again, the points are 0, 63, 1, 68, 2, 41, and 3, 8. So let me show you the first problem, problem number 1. I'm asking you to find a quadratic model for this data that AJ has given us. So how exactly are we going to do that? So let me pull up the calculator, because we're going to be using the calculator to do that. So let me pull it down here. So we need to find a quadratic model that represents this. So what do we have to do? Well, we need to plot these 4 points and then find the quadratic regression that best goes through them. So first I'm going to clear my calculator. To do that, hit second and then the plus sign, 7, 1, oops, 7, let's do that again. Second, mem, 7, 1, 2, your calculator is cleared. So now we need to find a way to put these 3 points into the calculator. To do that, remember you go to stat, and then you hit 1 for edit, and then you're brought to your L1, L2 table, x coordinates in L1, y coordinates in L2. So let's put these points in just like a normal XY table. So the first one would be 0, and then I'm just referring to the points at the top of the slide. 63, 1, 68, 2, 2, 41, and then the final point is 3, 8. This is all the data that AJ has given us, these 4 points. So now that it's in the table, what do we have to do next? Well, we want to plot these points and actually see them on our graph. So we can just hit second quit to leave the table. If we go to graph right now, we can't see anything. So in order to enable scatterplot will help us actually see these points. Go to your y equals and hit the up arrow so your cursor is blinking over plot 1. Hit enter to enable the scatterplot, and then let's see graph. Well, I only see 1 point, and this point is 3, 8, because remember, we're on the standard size grid, so it's negative 10 by 10 and negative 10 by 10. However, our y coordinates go all the way up to 68, so we need to change this so that we can see all of our points properly graphed. So in order to do this, we have to adjust the window. So go to window and scroll down to y max. The highest the ball is going that we know of so far from these points, our highest y coordinate is 68. So we should probably bump our y max all the way up to 80 to be able to see it. So now let's hit graph, and you should be able to see all 4 of these points. This 1 point over here is right on the y-axis. That's why it's not very visible, but it's right here. So these are the 4 points that are graphed. This one right here is 0, 63. This one is 168, this is 241, and this is 38. Now that we've already graphed all of these points, we need to find out what is the quadratic model that goes to them. So we need to find a quadratic regression that best fits these points. So in order to do that, go to stat, and then go hit right once for calc, and then you want to hit 5 for quadratic regression. So hit 5 for quadratic regression. You're brought to this new screen. So scroll 1, 2, 3 times down to store, and then you want to hit your vars key. Then you want to hit the right arrow to go to your y bars menu. Hit 1 for function. Hit 1 again for your y1, and then you'll be brought back to this screen, and then hit down so your cursor is clicking on calculate, and then hit enter. And then you are given this screen where your A value is negative 9.5, your B value is 9.3, and your C value is 64.3. Another way of reading this would be y equals negative 9.5x squared plus 9.3x plus 64.3. And if we hit graph, you can actually see this model graph, this parabola graph going through the points that AJ gave us. So if I minimize this, and I hit next, you'll see that is the exact solution. So y equals negative 9.5x squared plus 9.3x plus 64.3. That is how we found the quadratic model for this data that AJ gave us. Let's go to the next problem. Again, the 4 points are at the top of the screen. Here's problem number 2. I'm now asking you to use the model to estimate the height of the ball at 1.5 seconds. So what does this mean? We've been given seconds, so we've been given time. In this scenario, the time as in seconds is our x coordinates, and the height as in feet are our y coordinates. So I've given you an x value, I'm asking you for a y value. So we're predicting the y value based off of the x value, and I've shown this to you before, you've done it before, so let's do it now with this model. Let me pull the calculator up again. So we can do this on the calculator. In order to do this, you want to hit second, and then you want to hit the trace key. So you can go to the calc menu, and if you want to put an x value in to predict a y value, remember we're going to hit 1 for value, and we're brought back to the graph, but now we have x equals and our cursor is blinking. So we need to input whatever the seconds, whatever the time is at which we are trying to find the height. We've been told that the time is 1.5 seconds, and we're asked for the height at that time. So our x is equal to 1.5. So let me type that in, 1.5. Now that it is typed in, all we have to do is hit enter, and we are given the approximate height at that time. So at 1.5 seconds, the ball is at the approximate height of 56.875 feet. And if I put this calculator away and I just hit the next arrow, you'll see that that is the exact same answer. So again, we made a prediction for the y value because we were given the x value. We went to our calc menu, we hit 1 for value, we got the x equals, and then we put 1.5 in for x equals, and we found what the corresponding height was at that time. So that was pretty easy. That was problem number 2. Let's move on to problem number 3, our final problem. The coordinates are written at the top of the screen for you to refer to. So problem number 3. Find the maximum height of the ball. So let's think about this for a second. We already know that we're graphing a parabola because you already saw it on the screen. It's a parabolic shape. So when we're talking about parabolas, if the parabola looks something like this, if it looks like an upside down U, for lack of a better word, our vertex is at the top. Our vertex is the maximum height. Do you remember? Hopefully you remember that. When the parabola is shaped like a U, like a normal U, the vertex is at the bottom, meaning it is the minimum value. In this case, if we remember the graph on the calculator, our parabola was shaped something like this. So the vertex is up here. It is the highest the ball possibly goes. So imagine yourself throwing a ball. You're in your backyard or wherever. You're throwing a ball into the air. So it starts on the ground. You're tossing it upward. Well, does that ball just keep going upward, or does it stop at its very peak and then drop back down? That is the case. If you're throwing a ball, it also doesn't go towards the ground first and then upward. If you're bouncing the ball, that's a different case, but we're throwing it. So it's going upward and then coming back down. So that is the case here. So in other words, finding the maximum height of the ball, we're finding the vertex, and we're also finding the value of the function at the vertex, as in the y coordinate. So remember, your y coordinates are your height. So in other words, we're trying to find k, which is the y coordinate of the vertex. So let's do that right now. We put it in terms that our calculator can understand. And now let me bring up the calculator. so that we can solve this. So that we can solve this together. Okay, the calculator's up. Let's do this. Okay, so we're going to go to second, and then we are going to go to trace again. So we go to our calc menu, and this time you want to go to 4 for maximum. You're trying to find the highest point of the graph. So hit down for maximum, and then you can just hit 4 to select that. Remember the left bound, right bound, and then finding the vertex, and then you have to select those, and then finally the calculator will give you its best guess. Well, let's do that right now. It's asking left bound, which means we have to use the left arrow and go to the left side of the parabola. So I'm close to the left side of the parabola. I'm going to hit enter to confirm that, and then you just see this vertical line graph through that point that you just confirmed. Now your calculator asks right bound. So you're going to use the right arrow and go to a place on the right side of the calculator, which is pretty much complementary to the point that you just selected. So this is pretty much on the other side of this parabola. So I'm going to hit enter again. And then it's asking you guess. So you have to guess where the parabola is. Where the vertex of this parabola is. I'm going to use the left arrow and go to where I think the vertex is. And if you can't see it very well, but my cursor is actually blinking right there. I hit enter to confirm that. And then the calculator gives me its best guess. So this is the point that it's giving me. And you have to really focus on the y coordinate. The y coordinate it's giving me is 66.576, and I'm running it off here to 1. So 66.5761. So that's the approximation. If you look at the solution, that is the exact solution. So 66.5761 feet. If you remember, if you look at the points above, we have one point with an the y coordinate that's higher than this. Look at the point 168 at the top of the screen. Well, if you look at 68, that's the height as in feet. And the calculator is telling us that the highest y coordinate, which is the maximum height of the ball, is 66.5761 feet. How is this possible? Well, again, the coordinate regression model that we graphed is an approximation. Remember that. So it's not going to be exactly accurate. The actual answer should be 68 feet. However, your calculator is basing it off of the model that it found. So that's why you got a different answer, which is 66.5761 feet. Remember, it's an approximation. With real world scenarios, nothing's going to be perfect. Nothing is going to have a perfect parabolic path. So that is why your calculator gave you a different answer than 68, a different answer for maximum height, even though it is smaller than one of the points that we actually were given at the beginning of this problem. So if you're confused about if you're confused about why we got that answer, that's the explanation for that. So that's all I have for you today. I hope you enjoyed this video. I really enjoyed doing practice problems with all of you, and hopefully that TI calculator incorporation wasn't too hard for many of you. A lot of it was reviewing topics that we've already gone over in this Algebra 2 course. Remember, like I said, it's a continuous learning process. We're going to be bringing back concepts we learned before and incorporating them in very creative ways that you may not have imagined. Oftentimes we think of math as logical, but also there are creative applications to math, like how we just use that our matrix and our 3-variable systems to solve the first problem. That's all I have. Like I said, please like and subscribe to our channel if you enjoyed this video and would like to be part of the community that receives all of this information from AJ and myself. Hit the post notification button so you're notified of our latest posts, and please drop a comment down below of what you thought. Lastly, please share using our socials in the description box. Our website is going up soon. I know I keep repeating this, but I promise it'll be up and running soon. It has a bunch of sweet functionalities for all of you students, such as exclusive notes from AJ and myself, along with self-evaluation quizzes so you know where you are standing regarding a certain topic. Courses are also organized in the way that you would go through them in most schools. Again, different schools might approach courses and go in different ways. Go in different orders, but AJ and I have tried to organize them as much as we possibly can and give you some structure. So all that is organized and already done for you, and it's all free if you just sign up. So go check that out, please. And lastly, if you have any personal or business correspondences, please email us if you'd rather not put a comment under our video. That's all I have. I hope you all enjoyed this video and have a great day. Bye!